Hello. So I've gotten a few comments ever since I did the diagonal non-consecutive puzzles, as well as some other diagonal puzzles, requesting that I create a diagonal Miracle Sudoku. Well, ta-da, here it is. So for those of you who are not familiar with the Miracle Sudoku, it's a term coined, I believe Cracking the Cryptic coined it. They have certainly popularized the name. And it's the name of a very specific kind of Sudoku where you have king restraint, knight restraint, and the non-consecutive constraint. So I'll go over those in a second. But what I've done here is I've taken the same anti-king, the same anti-knight constraints, and instead of a regular non-consecutive constraint, we have the diagonal non-consecutive constraint. And yes, it is still constrained enough that we can have a board with two givens and it uniquely solves. So let me go over the rules real quick. So anti-king means that wherever you have a digit, say the 7, it means that wherever in chess a king's move away from that 7, so basically all the cells surrounding it, cannot also be a 7. So normal Sudoku already prevents these from being a 7, so really it just means the diagonals can't be 7. And then the knight restriction is a knight's move apart. So in the case of this 7 here, we have 8 cells that are a knight's move apart, and those also can't be the same digit, can't be a 7 in this case. These two are already in the same box, so they already couldn't be a 7, but for the center cell of the box, it's actually extremely powerful because you end up eliminating all of these cells that are knight's move apart. And finally, we have the diagonal non-consecutive constraint. I highly recommend some of my other videos if you aren't familiar with that, but basically what that means is if you take the cells that are diagonally adjacent to a cell, say this 7, these are diagonally adjacent, they can't be a consecutive digit with this one. So in this case, these 4 cells can't be 6 or 8. And in this case, that applies in the box and out of the box, because normally these could be 6 or 8. There's no reason they couldn't. So those are the constraints. Feel free to give this a shot yourself. If you want a huge hint on how to solve it, go ahead and watch Cracking the Cryptic's video on their regular Miracle Sudoku if you haven't seen that. But either way, give it a shot and then come back to see how I solve it. So just to let you guys know, when I look left like this, I'm looking at my other monitor. And so that has lets me look at what I'm recording. But I also, in the case of non-live solves, I also have notes for how to do the solve. So hopefully I can do this relatively quickly. There's a technique I'm going to be using through the entire puzzle, which is I'm going to be doing highlighting. And there's sort of 2 ways to do it. I prefer the way of highlighting the cells that can't be a certain digit. I think that lets me keep track of it a bit better. I do know some people prefer the method of highlighting what can be a certain digit. So if you do highlight that way, I apologize. I'm going to do the opposite. But hopefully you'll see the advantage of that. So I'm actually going to start with this 6 here. And then I'm going to highlight all the cells that can't be 6. So obviously the box that the 6 is in, that can't be 6. And I'll go faster after this first time. We've got the row and column. They can't be 6. So this is what normal Sudoku removes. We have the king's move, which removes all the ones surrounding the 6. And then we have the knight's move, which removes all of these. And these 2 but they're already marked. So you can see that the restrictions, just the king and the knight, make this sort of circle around the number, which can't be that number. And then we also have rays coming out, and then this weird oblong box because of the regular Sudoku rules. But in addition to that, this 7 diagonally constrains these cells. So these cells can't be a 6 because they would be diagonally just do a 7. And then, of course, this cell can't be a 6 because it's a 7. And 6 does not equal 7. You can learn things on my channel too, not just Cracking the Cryptic. So it becomes extremely plain after highlighting this that this is the only cell in the box that can be 6. So we're going to mark that 6, and we're just going to repeat that process. So I like to highlight the 6s that are already there. We could also leave them unhighlighted just so it's clear that the box has one. Maybe I'll try that. So we have the normal Sudoku. The box is already filled, but we have the columns and the rows. We've got the king, and then we've got the knight. So the knight can go up here, 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 and here, and here. So we'll highlight those. And what do you know? We got another 6. All right, and we're just going to repeat that process. We've got the columns already done, but we've got the row. The king's already done, but we do have this knight. So we have these 2 columns here. The 6s are used up. So we know in box 6 and in box 9, the 6s must be in columns 8 and 9. And because columns 8 and 9 only have 2 6s, and each of these boxes is going to have 1 6, that means that these can't be 6. I guess there's something else you could see is in column 7, this is the only place that can be a 6. So whichever way you want to do it, sometimes, I don't know, sometimes the hidden singles in a row or column don't pop out at you, and you'll kind of see this pattern instead. But either way, oops, boom, that's a 6. So this 6 actually sees this by knight's move, and now this means 6 is restricted to these 2. So that's a pointing, that points to these 2. These can't be 6. So now we can fill a 6 here. Trying not to miss anything here. That fills these as 6. So now these 3 are the only 6s left. And if we look, if the 6 were here, this cell is seen by knight's move. If the 6 were here, this cell is seen by regular Sudoku. And if the 6 were here, then this cell is seen by knight's move. So that's a regular knight's move restriction. We don't have to use king or non-consecutive. And that eliminates this cell. So now 6 is now limited to these 2. So that points up and down. And now we have another hidden single 6 here. That looks down, and we have a 6 here. So now, unfortunately, we can't do these 2 6s quite yet. We'll get to them, but it is limited to these 2. All right, so that is it for the 6s for now. So I'm going to clear the highlighting so we don't get confused. And really, the only other digit to try at this point, I suppose we could try 5s, but we're going to do 7s because we already have a given 7. So I'm going to highlight everywhere that can't be 7. So we've got the row, the column, and the box from Sudoku. We've got the king's move here. And then we've got the knight's move like so. All right, so we get our pretty circle there. And in addition to that, none of these 6s can have 7s diagonal to them. So what I'm actually going to do is I'm going to highlight the 6s as I fulfill all their diagonals, just so I know I don't miss any. Because I'm going to have to color the 6s anyway. And if you can see this in your head, all the power to you, but I definitely need the highlighting to solve something like that. So remember, now the highlighting is what can't be a 7. So there's just making sure I hit all the 6s before I continue. Okay, so what we can see is this first thing is that we have 7s limited to these 2. And I'm going to actually mark that with pencil marks. And so that prevents 7s from being anywhere else in the column. And we are going to, let's see, what's the next thing to see? This pattern here, these all see this one. So these 2 see it through king, this one sees it through Sudoku. Hopefully that's clear. And then what we can look at is row 7 and see that 7 is limited to these 3. So I can mark that. 7's one of these 3. So the first thing that's obvious from Sudoku is that now these can't be 7. The other thing to see is that with 7 and these 3, these 2 can't be 7. Because this one is seen by king's move or Sudoku. And then this one is seen by Sudoku, King's Move, or Knight. So those are not 7. So now 7 is limited to these two. And that points all the way back over here. And now we can actually place this 7. And that took the place of a 6. So we can place this 6. That removes that 6 and places this 6. So now we actually have all the 6s. And so next, these 7s across like this, they have a King's Move effect on this cell here. And then there's a Knight's Move or effect on this one here. So either the 7's here and it sees that from Sudoku, or the 7's here and we see that from Knight's Move. And of course, we placed this 7, we didn't fully utilize it yet. So through Knight's Move, it sees that cell. So that's no longer a 7. So now we can place this 7, removes that from being a 7, removes these from being 7. That places this 7. That through King's Move removes this one, and through Knight's Move removes that one. So now here's a 7 here, 7 here. I'll try not to skip too far ahead so that I don't lose my highlighting. So now there we have 7 here. It's pretty plain to see that these are the last two. So I can actually clear my highlighting because we have all the 7s now. All right, so next we are going to look at 8s. We could look at 5s. I mean, there's not really any particular reason to choose 5s or 8s over each other, but I like the path where we do 8s next. So that's what we're gonna do. I make the videos, I make the calls. All right, so we are just again highlighting these 7s so that we know we haven't missed any, and we're going to highlight their diagonals as we highlight them. So just to make sure we hit every 7. Yep. So this is the pattern for 8s, and at first it is difficult to see anything. We can highlight these 6s to start with so that the pattern stands out a bit better. So the thing to focus on first is the center box, this pattern here. It doesn't look like much, but how does it affect this cell? So if an 8 were in either of these, it eliminates an 8 from here just by Sudoku. If an 8 were here, it eliminates by Knight's Move, and if an 8 were here, it eliminates by Knight's Move. So another way to put that is if an 8 were here, it eliminates everywhere an 8 can be in the center box, in box 5. So this can't be an 8. So now 8 is limited to these 3 in this row, in row 6. And all 3 of these see this cell here. These 2 see by Knight's Move. See they're a Knight's Move apart. And this one sees by Sudoku. So again, if we were to put an 8 here, it eliminates an 8 from these 3. So that's not an 8. So the next thing that I think is the cleanest way to progress is to look at this cell here. We want to eliminate this from being an 8. That's gonna give us a pointing pair 8 here, which will be very powerful. So what we're going to do is we're going to experiment with, well, what happens if it is an 8? And we're going to find a contradiction. And it's not very hard to find. So I'm going to color this red to mean that's theoretically an 8. And in this box, that eliminates these 2 from being an 8. So now we're down to just these 2. This actually does see up into here, though, and it sees these 2 by Knight's Move and this by Sudoku. So it eliminates those from being an 8, which leaves just 1 left. This is an 8. This sees this by King and these 2 by Sudoku. So those can't be an 8. And so now this is an 8. But if we look, this cell here sees this by Knight's Move and this by Sudoku. So now where can 8 go in this box? Nowhere. There's the answer. And so that means this can't be an 8 because it logically follows from here, if we were to place an 8 in here, it eliminates all the 8s from this box. So I can undo all the way back here, and I can actually mark this green because it can't be an 8. So now I'm going to corner mark 8s here because that means now we can say 8s can't be in this row. So next we're gonna focus a bit more on this row here with these staggered cells. And there's a configuration actually that we can see where, I guess the easiest way to put that is, if I were to put an 8 here, I'll just do another chain-like thing here, but you can see that eliminates that from being an 8. But also if we just mark that gray, we can easily see that makes this also an 8, which eliminates that from being an 8. And this by Knight's Move and this 8 by Sudoku forces an 8 here, which by King's Move keeps this from being an 8. So an 8 here forces 8s into these two, which we could have seen without highlighting, but I think highlighting is helpful for the explanation, which eliminates all 3 of these from being 8. So now there's nowhere to put 8 in this row. So what we can conclude from that is, because we started here, this now can't be an 8. So now if we look at these two cells, they actually both, through Knight's Move, this sees up into here, and through Sudoku, this sees this one. So no matter which one of these is an 8, that sees this one and eliminates that from being an 8. So the next thing I'm going to show is, we're going to sort of do a double elimination here. So we're going to imagine an 8 is in one of these two, and it creates kind of a pointing pair. So we're imagining 8 is in one of these two, and it points down. So what that's going to do is, it's going to eliminate these two from being 8. That's all we know about that. But we can see here that that places an 8 here in this box, and that 8 sees this through Knight's Move and this through Sudoku, and it removes all 8s from box 6. So there's no way any of these can be an 8, because both of them are going to cause that problem. So we can actually mark both of these green. And apparently I missed this one. This is diagonal with a 7. Sorry about that. But hasn't affected our solve at this point. Now we have this pattern again, and they both see this one. We have this pattern again. They both see this one. And next, wouldn't it be nice if this weren't an 8? Because we get this as pointing, that would give us that 8 and that 8. So let's try it. And we can see pretty quickly, this eliminates these two from being an 8. It also eliminates this from being an 8. And now we have this pattern again, which sees this one, preventing that from being an 8. So what do you know? That an 8 here actually eliminates all 8s from box 7. So we can conclude from that, this is not 8. There's now an 8 somewhere up here in the top row, which means this can't be 8. So now we can start placing 8s. So 8 is here. Again, I'm going to try to be careful about cleaning up all this stuff. This one is Knight's Move. That places an 8 here and here. I'm saying I'm being careful and at the same time placing multiple. I'm pretty sure this just finishes everything though. So I know I'm a little all over the place, but places an 8 here. 8's here because that sees this 8 sees this, that places an 8 here, this 8 sees that, placing an 8 here, and these two 8s see up here, placing an 8 here. All right, and I don't need to highlight the rest because we're about to unhighlight, but that is all the 8s. Our rain is getting longer. We've got a 6, 7, 8 rain coming down here. Maybe I should have called this rain. Anyway. So next we can choose to do either 5s or 9s. I chose 5s, so let's do it. So again, we're just going to highlight all the 6s, because obviously 5 can't be diagonal with 6. So we highlight the 6 and we highlight the 2 diagonals that are, or up to 4 diagonals, sorry, that are next to that 6. Let's highlight those. So make sure I didn't miss anything. Missing is bad. Not missing is good. All right, so now I can highlight all these other numbers. They also cannot be 5. Hopefully I don't have to explain that one again. All right. So the first pattern that we'll look at is the center box here. These two see this cell through Sudoku, and this one sees it through King. So there's a 5 somewhere here Therefore, there's not a 5 here. And I believe that's all the immediate patterns we can look at. I apologize if I'm missing one here. But what I chose to do next is look at this cell here. If this were a 5. So what that's going to do is it's going to eliminate these two from being 5, which leaves just here for a 5 in the column. I don't know if you guys prefer me to do the extra highlighting or not. I might as well do the extra highlighting. I feel like when I do the highlighting, people are going to comment, oh, you're doing bifurcation. But if I just try to point it out without highlighting, then it's going to be harder for you to see. So I'm just going to do the highlighting because I think it's clearer what's happening. So we can see in this box here, this is the only place for a 5. I'm sorry, I'm going to use reds for here. The reason I did purple here is to say this is the one we were experimenting with. And I guess I should be clear. The reason for that is that leaves a pointing pair here, which would then also leave a pointing pair here. It's going to be very powerful. So this 5 here sees this, and it sees these two. That leaves just here for a 5. And so that leaves just here for a 5. That sees these, all of these. This is Knight's move. Hopefully I don't have to keep explaining that. But then this 5 here sees these as well. So now there's nowhere for a 5 in box 3. That means this can't be a 5. Same old deal as usual. So that's not a 5. So that means a 5 is in one of these two, which eliminates this from being a 5, which means a 5 is one of these two. And we finally have this pattern. This is actually just a Knight-King pattern here. So it's the same in both variants of Miracle Sudoku. But if we look, when we have two values like this stacked on top of each other, the entire ring around them can't be the same value. So in this case, none of these can be 5. So I'm just going to go over that real quick. If you've watched the original Cracking the Cryptic Miracle Sudoku video, Simon does explain this as well. But here, if the 5 were here, obviously through king, none of these can be 5. And this can't be a 5 because of Sudoku, but also these two are knights move apart. So hopefully that's seeable with my highlighting, but you can see this whole ring is not available if this were a 5, and then it's symmetric. So if this were a 5, these can't be seen through king's move. This can't be seen through Sudoku, and these two can't be seen through knight. So the union of those, or sorry, the intersection of those, I should say, is these. So when we see this pattern, we should immediately be going, okay, is there a donut around there? And we can immediately see that these two can't actually be 5 because of that pattern. And that eliminated one of our pencil marks. So that places a 5 here, and that's going to be obviously super useful. So that places a 5 here, eliminates these, places a 5 here, that eliminates these two, and it eliminates this by knight. So now this is a 5, eliminates here, that places a 5 here and here. And we need to make sure we clean up everything from those. This is seen as a knight's move from here, also seen by this 5. As I say, I need to be cleaning up better. I failed to clean up from this 5. Anyway, this is another stacked pair here, but I mean, the donut doesn't eliminate anything. We should be able to finish up though. So 5 is here or here. Sorry, I was about to do something complicated when something simple will do. So that's not 5. 5 goes there and there. All right, I'm going to finish that highlighting just to show. So now we have all of the 5s. I think by now you guys are noticing a bit of a pattern. We can't depend on it, but it's really looking like the numbers are all stacked. We got 5, 6, 7, 8 raining down now. All right, so we're on a roll just decreasing. So I think we can predict where the 4s are going to go, but unfortunately, we can't just guess. We are going to have to actually prove it. So, but I think at this point we can start keeping in mind that if we're going to look for a contradiction, maybe we shouldn't look for it in these squares. Anyway, a little spoiler for you there. But we're going to look at 4s. So I'm going to highlight all the 5s. and their diagonals to start out with. And this is just, again, to make sure we don't miss any. Oops, not that one. Don't highlight too many things. All right, so that should be all of the 5s. And of course, we can highlight the 5, 6, 7, 8s because they are not 4. All right. Does this look right? So the first thing to see is that in column 2, these are the only 2 spots that we can have a 4. So, I mean, this is just Sudoku. We haven't even done anything with the other constraints. So that eliminates 4 from these. That means in column 1, 4 can be, oh, oops, wrong mark. 4 can only be in one of these 2. That eliminates a 4 from here. And so, of course, now 4 is limited to here. And what do you know? We got our donut again. It's kind of an oval donut, but it's a donut nonetheless. So that eliminates these 2 from being 4. And that took one of our pencil marks. So that is extremely useful. You can place this 4. Let's make sure we get all the consequences from that. There we go. That was so many consequences. And of course, next we have another donut. Yay, I love donuts. I hope you like donuts too. We have a lot of them. So that donut eliminates that. And actually we have this pattern does more than just that. Points up here. But when you have a stack like this, if you look at the knight's move, this 4 eliminates here. And this 4 eliminates here by knight. And they're also seen by Sudoku. So if the 4 were here, it sees this by Sudoku and this by knight. And if the 4 were here, we see this by Sudoku and this by knight. So in any just knight constraint puzzle, if you see this stack, you should also be looking at the parallel boxes that are 2 away, because those are gonna be eliminated. So that eliminates this one. We could have done that here as well, but it wasn't necessary. So that places a 4 here, which then turns around and places a 4 here. You notice miracles get easier as you fill digits, which makes a lot of sense. Now we just get that full ladder. What do you know? We're above 5s. All right. That leaves here. King and Sudoku places a 4 here. And finally, this 4 sees here, placing our last 4. That was easy. So now we can clear out all these 4s. And yes, I do see that pencil mark. I will remove it. Removed. All right. So now I chose to do 9 next, and let me justify that. If I do 9 next, we get 1, 2, 3s for what's remaining. And 1, 2, 3s are all consecutive. So that makes for some fun. All right, so I'm going to highlight the 8s. And honestly, at this point, you could really do anything you want and solve this puzzle. It is very constrained at this point. But that doesn't stop us from having fun. All right, so we're highlighting all those 8s and their diagonals. Make sure I didn't miss any. All right, and of course we can highlight the 4, 5, 6, and 7s as well. All right, so where can 9s go? Well, we have this pattern again. So these 2 see this one by knight and Sudoku. That gives us a pointing 9s here, points over to here. And now we have a donut. So this donut, again, not only does it do the donut, it also does a knight over here. So we get 9, 9, 9. I sound German now. 9, 9, 9. Don't even have to highlight. I'm sorry if you really wanted me to. In fact, yeah, actually, let's do some highlighting just so it's easier to see what's going on here. And that's king move. This 9 sees these 2. So we have 9 here. King sees that, so 9 goes here. And this 9 is seen by here, so there. Now we have all the 9s done. It's going a lot faster now. Let's unhighlight. Okay, so that is the last bit of highlighting we're going to do. We're going to have some funs with 1, 2, 3s now. So we're just going to highlight everything that's not filled, and we're going to type 1, 2, 3, and then we're going to eliminate. And we're going to have fun doing that. All right. So 1, 2, 3. Yay, that was fast. So the first obvious thing to do is we do have 4s placed. So anywhere that we're diagonal with a 4, I'm actually just going to highlight. Well, let's do it this way. Let's highlight that, and I just don't want to miss any. This 4 seeing that one. This 4. Actually, let's highlight the 4s as we do them. That sounds nice. All right, this 4 sees that one. This 4 sees that one. This 4 sees that one. This 4 doesn't. Oh, that sees that one. Okay, so we can now. That's it. The 4 is obviously consecutive with 3, so we're removing 3 from all of those. Hopefully I didn't miss one. Should solve anyway. And now the next thing I'm going to point out is this little pattern here. Now be careful with normal non-consecutive diagonals, because this doesn't always hold true. But with non-consecutive diagonals plus king, what we can say is that 2 diagonally apart 1, 2, 3s cannot have 2 in either of the cells. So there's a few ways to see that. One way to explain it is, if this were a 1 or a 3, that eliminates 2 from here, because both 1 and 3 are consecutive with 2. If it were a 2, it eliminates a 2 from here because of king. And this does it right back at it. The other way to see that is, if I were to place a 2 here, that eliminates a 2 by king's move and a 1, 3 by non-consecutive. And now there is nothing that this cell can be. So what we can do is we can find all of the 2 3s that are diagonal with each other. This is the fun part. Got a lot of them. And we can eliminate 2 from all of them, making all these 1, 3 pairs, which I'm actually going to highlight. So now in any of these rows, columns, or boxes where we have a 1, 3 pair, we can actually place a 2. So whether it be a 2 here, a 2 here, this column gets a 2. Everyone gets a 2. All right. This row gets a 2. This is why I wasn't too concerned about the diagonal 4s, but so we can place a 2 in all of these. And let's see, these 2s see here. Did I miss something? Ah, yes, I missed this 2 here. That sees up here. These highlighted 1, 3s are starting to confuse me a little bit. All right, so this 2 here. This is now a 1. And really, we're just solving the puzzle at this point. So now we get 3, 1, 3, 1, 1, 3, 1, 3, 1, 3, 1, 3. All right, let's unhighlight those. And we get a 2 here for the row. 1, 3. And this 1 is seeing these 2. This 3 is seeing this one. So we have 2, 1. And this 2 is seeing here, 3, and 2. And oh, almost missed 1, 3. All right. So that is how you solve the diagonal miracle. All right. So I hope you enjoyed the video. I hope you enjoyed the solve if you tried it yourself. Honestly, the puzzle basically solves itself. There's a little bit of logic you have to do and some nice patterns you have to notice. We did have to do some interesting, like, oh, if the 5 were here, then it eliminates all the things from this other box. I'm curious to know if any of those were unnecessary and I was just missing a pattern that I wasn't seeing. But either way, that is a way to solve this. I'm sure there's other ways, because there's always a choice of 2 digits. When you're solving. You could even like skip ahead and maybe go, oh, well, where could 4s be at this point when I don't have all the 5s yet? And maybe start filling in candidates earlier than just the 1, 2, 3s and look for spotting some diagonal logic. Anyway, however you want to solve it. I mean, of course, now that I've shown you how to solve it, I'm not sure what the point is of explaining all these things, but yeah. So that's it. If you enjoyed this puzzle, then it's helpful to subscribe because you'll get more like it. Other than that, I'm gonna put some boxes up. I'll make them 2 diagonal videos to other puzzles I've made for how-tos, and you can see how to solve those as well and try them yourself. And until next time, thanks for watching.